Hello students, today we're going to continue our lesson on solving and graphing one-step inequalities. In the last lesson we talked about reading and writing inequalities, where we translated a statement into an inequality statement. Then we learned about graphing each solution. So let's just review that real fast and then we'll move on into our lesson. So we'll do the first one here. It says there are at most 25 people in the class. So if you remember from the lesson last time, first thing you had to do was pick a variable. So in this particular one, I'm going to pick the letter P. And then you're going to write the number down. And now we have to look for phrases that represent an inequality. And this says at most 25 people. So at most 25 people means that 25 is the most that there can be. So that means the variable has to be less than that. So we know that the P is going to be less than 25, but could we include 25? Could there be 25 in this one? Well, at most means less than or equal to. That is correct. Okay, so that was the first thing that we looked at. We looked at reading and writing inequalities. The second thing was graphing a solution set. Now, in each of these, what we're just going to do is what we call a quick graph. So in other words, right in the middle, and we'll just put a 3. And then I'm going to either put an open circle or a closed circle. So in this particular one, because it says greater than 3, that means that we're going to put an open circle on 3 because it's going to be bigger than 3, but it's not going to include 3. And then what we're going to do is we will shade our number line all the way to the arrow and shade the arrow. Now, if we look at the second one here, the x is less than or equal to -2. We'll do the same thing, and we'll put a tick mark right in the middle and put a -2. But this time, because it says less than or equal to, that means I'm going to shade in my circle. Okay, I'm going to shade in that because it's closed. It's going to include -2. And then this one says I need x is less than or equal to -2, so I shade to the left of. Now, I do want to look at this last one just for one very quick reason. Okay, this one says 5 is less than or equal to x. This one's backwards. Okay, so I'm going to do the same thing. I'm going to put a tick mark in the middle. I'm going to label it with a 5. And I know since it's less than or equal to, it's going to be a closed circle. But it says 5 is less than or equal to x. Okay, so that means that 5 is actually a minimum number. It's a small value, smaller than the x. So basically what this is I need the values that are greater than 5. Okay, so I'm going to show you a trick real fast. Okay, so if our variable is on the left of our inequality, the inequality tells me which way to shade. So in this first one, it's a greater than, it says shade to the left. The second one says less than or equal to, so it says shade to the left. And I think the first one I said to the left, and I meant to the right. But in this last one, it says 5 is less than or equal to x. So there's two ways of thinking about this. Either think about the inequality. If the variable is on the right, my inequality tells me the opposite direction of which way I need to shade. I need to shade in direction of the inequality only if the variable is on the left. But if the variable is on the right, we've got to do one of two things. Either think about it differently or flip it. Okay, now if you wanted to flip it, I could write the x and then write the 5, and then just make sure that that inequality is still eating the same thing. Okay, it's pointing to the 5 or eating the x, so I needed to do the same exact thing when I flip it. And now I can shade according to the inequality. Okay, so that's just kind of a few side notes about what we were doing last time. Now in this video, we're going to learn about adding and subtracting, multiplying and dividing inequalities. So let me ask you a question. When you add or subtract the same number to both sides of an inequality, would the resulting statement be true? Okay, so that's a question. This one says that the statement will be true. So if I have the -2 is less than 5, if I had +7 to both sides, I'm going to get 5 is less than 12. Is that still a true statement? Yes, it is. Well, you can find solution sets of inequalities the same way you find solutions to equations, by isolating the variable. So my one question is, do you think we would solve an inequality the same way we would solve an equation? And the answer is yes, we would. So let's see what we've got. So here's our first problem. Okay, and the problem says n minus 7 is less than or equal to 15. So if this were an equation, if this were an n minus 7 equals 15, what we would first do is change my subtraction to addition next to its opposite, and then I would move the -7 to the other side by adding a +7. So n is equal to 22. Well, in this previous statement, it just said that you can find solution sets to inequality the same way you find solutions to equations. So would I do the same thing? Yes. Okay, I still change my subtraction to addition next to its opposite. I still move this -7 to the other side. So or first off, how do I get rid of that -7? Sorry about that. I add a +7 and add a +7, and I end up with n is less than or equal to, and when I add those together, I end up with 22. So in an equation, this 122, it's the only number that would make it true. But in an inequality, any number less than or equal to 22 would make it true. Okay, so if I were to graph this one, this says I'm going to put an closed circle on 22, because 22 will work, and I will shade to the left, because my variable is on the left, so my inequality tells me which way to shade. So if I were to pick any number that fits within this range, it would make it true. Well, anytime this number right here is in the range, I always use it. So let's pick 0. So if I were to plug that in, 0 minus 7, is that less than or equal to 15? Well, 0 minus 7 is -7. And is that less than or equal to 15? Yes, it is. That's all there is. So what you see is you solve them exactly the same way. So what if I gave you this one? A minus 10 is greater than or equal to -3. Pause the video and you solve this one for me. Okay, so let's see how you did. First thing I'm going to do in a problem like this is I'm going to change my subtraction to addition next to its opposite. My letters are together on the left, so I need to get my numbers over on the right. Okay, so to get rid of that -10, I'm going to add a +10. I'm going to add a +10. My 10s go away, and I'm left with A is greater than or equal to, and then -3 and 10 make 7. Okay, so that means that I'm going to have a closed circle on 7, and I'm going to shade to the right because I need values that are greater than 7. So here's one. I'm going to pick 10. 10 will work to check it with. So that's going to be 10 minus 10. Is that greater than or equal to -3? Well, 10 minus 10 is 0. So is 0 greater than or equal to -3? Yes, it is. And that's how you solve inequality statements. It's all there is to it with plus and minus. Okay, so let me ask you then, what about multiply divide? Well, let's take a look. If you were solving equations, what would you do to get rid of the multiply by 4? Good, we would do a divide by 4. And if I divide both sides by 4, this 4 divides out to a 1, and we have 1x equals, and -12 divided by 4 gives me a -3. So the solution to that equation is x is equal to -3. But what if I have a divide by 5? Now, this is what many of you had some trouble with on your test and on your assignment. If I had to divide by 5, we're going to do a multiply by 5 to get rid of it. And so I do a multiply by 5. So these 5s now divide out, and I'm left with m is equal to 20. Now, those are the only two solutions to those problems. Well, in an inequality statement, you're going to have multiple solutions, but you'll do the same exact thing. There's only one minor difference. We'll talk about that in just a moment. So here I've got 3x is greater than 15. Well, I don't want to know about 3x. I want to know about x. So to get rid of a multiply by 3, I do a divide by 3. And I end up with x is greater than, and then 15 divided by 3 is 5. So if I do a quick graph, we'll put a tick mark, put a 5. Since it's just a greater than, I'm going to do an open circle on 5, and I'm going to shade for values that are to the right of it. Now in the second one there, I've got to divide by 7. So how do I get rid of a divide by 7? I do a times 7 times 7. So r is less than or equal to -28. So I'd put a tick mark in the middle, put a -28 underneath it. I'd put a closed circle because it does say less than or equal to -28. And I need values less than, which means left of. So that would be my graph. Just like that. Pretty simple. Okay, so let's try this one. Now, let's go back to these real fast, and let's just double check to make sure that this is the correct answer. So this says I need values that are greater than 5 to make it true. So you pick a value to test it with. I'm going to pick the first value that comes to mind, 6. That's greater than 5. So I'm going to pick that 6, and I'm going to do 3 times 6, and I'm going to ask, is that greater than 15? Well, 3 times 6 is 18. Is 18 greater than 15? Yes, it is. In this problem over here, the second one, we got to be a little bit more choosy of what number I'm going to pick. I need a value that's less than 28, but yet divisible by 7 because I want it to come out nice. And the first number that comes to mind is negative 35. Okay, so negative 35 divided by 7, is that less than or equal to negative 4? Well, negative 35 divided by 7 gives me a negative 5. Negative 5 is less than or equal to negative 4. Is that a true statement? Yes, it is. Okay, so we should always check our answer to make sure it's correct, just to be on the safe side. So now let's talk about this one. This one says negative 5g is less than 20. Okay, so if we were to solve this, how do I get rid of the negative 5? Well, I do a divide by negative 5 because I had to multiply. And then I'm going to do the other side by the same way, divide by negative 5. They divide out, and I get a g is less than, and 20 divided by negative 5 gives me negative 4. So what we need to do is we need to check this to see if this is right. So g is less than negative 4. So I need a value that is less than negative 4. Well, value less than negative 4 is negative 5. So let's try that one. Negative 5 times negative 5, is that less than 20? Well, negative 5 times negative 5 is 25. Uh-oh. Is 25 less than 20? No. But that's the first value that's less than negative 4. Let's try another one. What if I gave you negative 6? Okay, so negative 5 times negative 6 is less than 20. Well, negative 5 and negative 6 make 30, is less than 20, and that's not true. Okay, and you'll notice as I increase that number that's less than negative 5, or make that number smaller, okay, as I increment that one, okay, my value gets larger. That doesn't make any sense. So what do you think's happening? I need to get a value that's less than negative 4. Okay, well, all of those seem to work, but what if I chose a value that was greater than negative 4? What if I chose the other way? Okay, what if I used 3 instead? Okay, well, if I chose 3, negative 5 times negative 3 is less than 20. Well, let's see, negative 5 and negative 3 make 15. That is less than 20. So how come when I chose a negative 3, it works, but numbers that fit the criterion, they don't? Well, here's what's going on, and this is what you need to know, because there is something happening here. So let's talk about that. Get rid of all this, and let's find out what's happening. Well, the math is the same thing. We still are going to divide by negative 5 and divide by negative 5. But what I need you to understand is if I divide or multiply by through with a negative number, my inequality is going to flip-flop to the other side. Okay, so instead of this being g is less than negative 4, it's going to be g is got to be greater than negative 4. So how many of you have ever gone fishing? Okay, well, fishing's pretty cool. Okay, so basically the premise then is you put a hook on your line, you bait that hook, and that hook's got a little barb on it. Okay, and that barb is what allows you to hook that fish and it not slip right back out of the fish's mouth. So you cast out your line and you start reeling it in and you catch a fish. So first thing you do when you catch a fish is you pull tight to set the hook. And what that does is that takes that barb and jabs it off into the fish. And so that fish can't pull it back out. That's what this negative is like. This negative is like, what happened there? This negative right here on this 5 is like that little barb on the fish. What it's going to do is it's going to hook and flip that inequality. Because once you've set that hook, that fish is going to take off running. And you start reeling it in to flip the fish the other direction. So what's going to really happen is anytime you multiply through or divide through by a negative number, that inequality is going to flip-flop on you. Okay, so if it was less than, it's going to flip to a greater than. If it was greater than, it's going to flip to a less than. And then, of course, we graph our solution. So I put a negative 4 right here in the middle. I put an open circle on negative 4, and I need values that are not less than negative 4, but greater than negative 4 to make this work. So if we pick a value just to see, one value that's greater than negative 4 that I like to use is 0. So negative 5 times 0 is less than 20. So I plug that value back in the original equation and I do the math. Negative 5 and 0 make negative 5, or make 0, sorry. Make 0. What am I thinking? I'm thinking about something else. Okay, negative 5 and 0 make 0, and is 0 less than 20? And sure enough, it is. Let's do another one real fast. Okay, so here we got a C is divided by -3 is less than or equal to 6. So to get rid of that, I'm going to multiply by -3, and I'm going to multiply by -3 on this side. So these -3's go away, and we're left with C. On the other side, I end up with -18, but because I multiplied through by a negative number, my inequality is going to flip to the other side. So in order to determine an answer on this one, I need a value that's greater than or equal to -18, but yet divisible by -3. Okay, so I'm going to pick a value that's easy to use, 0. 0 is greater than -18. So if I plug that back into my problem, 0 divided by -3, is that less than or equal to 6? Well, 0 divided by -3 is 0, and sure enough, it is less than 6. So in review, with multiply, if I multiply through or divide through by a negative number, my inequality is going to flip. Okay, so let's try a couple of these. The first two, I got 6x is less than or equal to -18. First off, is that 6 positive or negative? It's positive, so nothing's going to happen here. I divide by 6, x is less than or equal to -3. Tick mark, -3. Close circle on -3 because it's got a bar, and I need to shade to the left because I need values less than -3. Okay. The one right beside it, I got t divided by 5. Is that positive or negative? Positive, so nothing's going to happen. So I multiply by 5, I end up with t is greater than or equal to -35. So if I wanted to pick a value, I'd pick a value that's greater than -35, 0. T divided by 5, or 0 divided by 5 is 0. Is 0 greater than -7? Yes, it is. Now in multiply, we have to look for our negatives, okay, and divide. So in this one, I got a -9, so I'm going to divide by a positive or -9. And so when these 9's divide out, my -81 divided by 9 gives me 9, and my inequality is going to flip-flop. So I need values that are greater than 9. So open circle on 9, shade to the right. Now this negative, no matter where the negative is, it doesn't matter. You can put it on whatever number you want. So I'm going to put it on that number right there. You can't, it's got to be on the left-hand side though. So I put it on that -3 right there. Put it on that 3 to make it negative. So that means I need to multiply by a -3. And if I multiply through or divide through by a negative number, these divide out, and I'm given 1. I'm given -15. But my inequality is going to flip. Anytime you multiply through or divide through by a negative number, the inequality is going to flip. So now I've got a -15. This is going to be a closed circle on -15, shade to the left. And that's all there is with solving inequalities. So, a couple things in review. Do we solve an inequality the same way we solve an equation? Yes, there's only one minor difference. One minor difference. So in addition, you're going to still add the opposite and solve. Same thing. But in multiply divide, we're going to do things a little bit different. Okay, we need to remember that if I'm multiplying through or dividing through by a positive number, nothing changes. If I multiply through by or divide through by a negative number, my inequality is going to flip before I come up with the solution. Okay, so what we're going to do for our assignment today, something real simple. We'll just have you do a series of addition and subtraction problems and graph their solutions. And we'll have you do a series of multiply and divide questions, but no graph of the solution. So until next time, I'll talk to you later.